There we go. So here we are. We're going to talk about something called control flow today. Control flow, pretty much if and else. We're going to add a little bit of logic to our programs to make them a little bit smarter. So let's start off with a review, a little bit of yesterday, just to kind of recenter ourselves. What? Oh, that's so cool. Sorry. Slides are cool. Slides.com is an amazing place to do PowerPoints because, like, behind the curtain a little bit, like, on my second screen, I have this, so I see what's coming and everything. And, like, I could change this slide without changing the actual slide. And so that's really cool.
And there's a timer.
Yeah, there's a timer and a clock and notes there. It's really cool. And if I want to get fancy, I could control this from my phone as well.
Are you crazy?
I know.
Are those portable network graphics from CodePen?
These things? No, they're actually code samples. They're actually code samples. Like, they have a type for code samples at slides.com, so it's actually like code. Cool. Anyways, if else. So yesterday we talked about JavaScript. A few basic things, right? We established 3 types of variables. Count and number, so things we can store numbers. We can store strings, so actual words, and we can have functions, because functions are just data in JavaScript. So we can store these 3 things in JavaScript right now. How are we feeling with these? Okay-ish?
Yeah, I think the arrow
Hardish.
functions are confusing.
Yeah, the functions are kind of the hardest stuff to wrap your head around because it's a really abstract concept. But, it's a thing. So we're going to add one more type to our bucket of types. And today that's a boolean. Booleans dictate on or off, or true or false. It can be one of 2 values, yes or no, and that's it. Very constrained, very straightforward, simple to use, simple to understand, hard to master. Yeah, this is also one of those honeymoon things like booleans, yay. True or false? Got it. That's it. That's the only values we can do. But what we can do, those, is that we can use these to go, hey, if something is true, then do this, else do that. And that structure of if and else is what's called an if statement. So if statements allows our programs to make decisions based on yes or no value. So I can go like, hey, if this is a laptop, turn it on. Hey, if that text field is empty, throw an error. And then add a red border to it. We can start to do stuff like that. There's a huge joke in the developer community right now about artificial intelligence. That all AI is just a whole bunch of if statements. Like, hey, is this a coffee cup? No. Is this a water bottle? No. Is this a computer? Yes, that's a computer. And that's all AI is. So it's just kind of add a little smarts to our program. So what does it look like? Here's a very simple if statement. Of some Boolean value, this number pseudocode needs coffee. We're going, if needs coffee, refill coffee, else get work done. And at the very bottom, relax. So how this works in sequential order. It's going to run the first line first. It's going to create a new variable called need coffee. Set it equal to the value of true. You notice true here is all lowercase. There's no quotes, so it's not a string. It's an actual value true. That's a keyword inside of JavaScript. Now on the next line, we're going if need coffee. That's saying, hey, if the value of need coffee is true. So if it's true, then it's going to run refill coffee. Then it's going to skip over the else statement. And then it's going to go to relax. So that if else creates a branch inside of our logic. On the flip side, if need coffee is false, so if this was flipped to false, it's going to go, hey, is need coffee true? No. it's going to skip this and run get work done. And then it's going to run relax.
And we would have to define refill coffee and get work done somewhere else.
Yeah.
Okay,
Yeah.
sure.
I sometimes put functions like this just to represent work, because it doesn't matter what that work is.
So when does it run relax? Is that part of the need coffee?
That is at the very last. So regardless of what happens here, this is going to run,
Okay.
because it's outside of the squiggles.
Okay.
So relax will run no matter what.
Yep. Regardless of what this is, it's going to do its logic, and then it's going to run this.
But it's still considered part of the function, or is it just like out? Just
It's
its own
outside
thing,
of it,
own
yep.
entity. Okay.
So what would relax be? Just
Whatever you do to relax.
So in this case, you don't have to say if need coffee equals true. It's already defined as true, so it's going to run automatically.
Exactly. Anything that goes inside of this parenthesis, that's what's called an expression. It just needs to evaluate down to true. So here we just have a straight up true value, right? We're saying, hey, we have a Boolean value of true. Well, that's fine and dandy, but we need to somehow be able to compute those values. So with the expressions, that's a really good segue into the next slide. JavaScript, we can do basic comparisons as well. So comparisons are the greater than and less than or equal to and greater than or equal to. Those all work as we kind of expect them to. So if we have, can you see that in the back? So we have two variables, number of red crayons and number of blue crayons, equal some values. What we can do is that we can use our less than, greater than, equal to, less than or equal to signs to actually come up with a Boolean value. So I could say stuff like, hey, if number of red crayons is greater than or equal to the number of blue crayons, run this code. If number of red crayons is less than the number of blue crayons, then run this code.
So after that, you'd put your squiggles or your function or whatever.
Yep.
Do you have to have an if there? Or
Yeah, these are just code samples, but yeah.
Okay.
And we'll get to a full sample in like 3 or 4 slides.
So you likely put this in a function.
So also with comparing, we also have equality as well. We can go, hey, if these two values equal each other. Current, as we see, like current score equals target. So that'd be, does 10 equal 15? False. Does 10 equal, or says 10 equal 15? False. Does target equal score? So does 15, or sorry, current score equal target score? So does 10 equal 10? Yes. Now, JavaScript being the dynamic typing language that it is, the syntax for equality is either double equals or triple equals. This is where things get interesting. So triple equals checks for value and type. So the types have to match. Double equals just checks values. It doesn't care about types.
Should we just always use the 3 then?
Yeah. Probably 98% of the time you should use the 3, but doubles do exist.
so to be safe,
Use 3.
and that checks the value and the type.
Because if we see there, we have the string 10 and the value 10, right? The actual number 10, and current score and score string. That will actually value to true. Because it's saying, oh, you're giving me a string 10 and a number. I'm going to convert this string to a number and see if they're equal.
And the string is a type.
If you wrote the word 10, it would be a string,
Correct.
and then they would not be the same because
Correct.
they're different values. Okay.
Yeah, so if you had actual like TEN,
Yeah.
TEN does not equal 10.
Great.
If you parse int on like the string 10 with the triple equals,
Yep.
they would equal each other.
Yes. And that's really what you should do. And if you're looking for like the value 10, the actual number 10, you should say, hey, take that string, convert it to a number for me, and then check to see if that's equal or not.
What was parse int again?
It converts a string to a number. Specifically a integer, a whole number.
String is in.
Yep. So now that we have some comparisons and some ifs, let's kind of put it all together and make sense of all of this. So here's probably a more realistic sample of an if statement. We have an if some condition. If the current score is less than or equal to the target, we want to try again, whatever that is. Else, we want to display a message. Probably like a winning message or a losing message for playing golf or something like that, just some sort of message. So what this does, this defines a variable, current score equals to 10. Defines another variable, const target equals 15. So now we have 10 and 15. And then if the current score is less than or equal to the target, which it is, the evaluates to true, then it will run try again. It is going to skip over the else. So that display message is never run. How are we feeling?
If we had to put this in a console log, what would we put that console log at the bottom?
So-
So we want to console log this out so we can see if it works or not.
So depends on what you want to see is working. So pretty much what I would do is I would put a console log right here and also right here to kind of dictate like, oh, am I getting to the truth branch or am I getting to the false branch?
What does console log say?
Got to the true, got to the false,
Oh, okay.
Yeah.
whatever sort of message.
Yeah, well, you could put in there, hey, I'm running this just text, so it's a string, and your top if and your else, and say,
Yep.
hey, this is true to your console log, or hey, this is
false.
else
Yep.
to your console log, and then
Okay.
that what it does is, fire up a string.
Yep.
Whatever you throw in there is gonna fire up. So
Just like yesterday, we put like console.log, like button was clicked, or add one button was clicked. So like
Yeah.
that, you can do the exact same thing.
But the computer doesn't know that just something happened.
Yeah.
So it's just things.
Yep.
Wait, you put a blank console log?
You log out like
You could.
hit the truth value, hit the blank value.
Uh,
Always console.log something.
So once you run through this if statement, you either get the true or false answer, and you do the true or false thing, and then you're done. You're not like continuing to loop through here.
Correct. Yep. It's just one pass and that's it. Kind of like yesterday, our scripts were once the event was run, it's not running the event over and over and over again.
You are blowing out.
D&D, man.
Oh, yeah, we're trying to schedule a session and it's hard. Scheduling 4 people.
People are adults.
They are. Like, we have one person who's like, we have one couple and like,
Oh.
she's just graduating from grad school or she's finishing up her semester. She has to work and they're pregnant and they just bought a new house.
Oh my gosh.
So like, great.
She's not that.
They're just
Yeah.
never couple.
Yeah. It's just hard to find 6 hours every other week to sit down and play.
Never gonna see them again.
Yeah. Yeah. Anyways, yeah, ifs. Okay. For now. So we're going to take this idea of an expression, we're going to expand it. We know we can do like less than and equal to's and inequalities and stuff like that. But there's actually another layer called boolean logic on top of it. This part might get a bit mathy. I know. You're gonna love the next couple slides too. But just bear with me. It actually makes relatively some sense. So we have 3 types of Boolean operators that are used pretty much in every language. There are more, but these are the 3 big ones. We have and, or, and not. And pretty much what this is saying, hey, take some Boolean values and compute a new Boolean value. So in the same way we have addition and subtraction and multiplication and division for numbers. Like addition, take 2 numbers, give me a new number, right? Boolean operators work the same way except on Booleans. Given some Booleans, do some stuff, and give me a new Boolean. Take a deep breath. So the first one we're going to talk about is and. And says, hey, give me two booleans. If they're both true, then return true. If either one or both is false, then return false. It's like saying, hey, I'm wearing a hat and a watch. That is true. So const nice outside equals the result of if it's sunny and not too hot. So if it's sunny and not too hot, if those are both true, then nice outside would also be true. If either one of those is false, then nice outside is false. If it's not sunny, if it's too hot or too cold, or if it's raining or anything like that, then it's not nice outside. It's a false value.
Why didn't you always just use true then? Because false.
You're looking for a true value. Usually, yeah, that's the goal.
But if one or both is false, it returns false.
Correct. So if my
It
logic,
depends what you're looking for, right?
so if my logic is, do I want to go outside and go to the park?
Mhm.
I'm going to go, hey, is it nice outside? Well, is it nice outside is if it's sunny
Conditions.
and not too hot.
Mhm.
Like, or do I want to go to the movies?
Okay.
I want to go to the movies when it's not nice outside.
Oh.
So I'm going to look for both those to be false.
I got you.
So it's all what you're doing. Well, we can use this operation of and to kind of compute that inclusive terms.
Right.
Ors. So ors are kind of the opposite of ands. That's how I think about this. It's probably not 100% correct statement, but it's kind of like the opposite. Ors will return true if either one of those is true. So if good movie or raining is true, then should I watch a movie is true. They can both be true, but at least one has to be true. If they're both false, then it's false.
And it's represented by those two.
Can you put three terms in there?
So you can.
No.
Just like you can add three numbers together, it's going to evaluate the first two and then evaluate the third one.
And technically, there's an infinite amount that you can
Yeah.
include in there, as
Yep.
long as one of them is true, it will return.
Right. So should I watch a movie? If it's a good movie, or it's raining, or I'm bored, or I need to get out of the house.
So it compares it with the first.
It compares it with the result of the last.
Oh, okay.
So,
But how does it? What does it compare the last one to? Does it
So-
jump
So it
all the
compares,
way to the end?
it compares the first two, and then once you get
So-
an answer, it skips to the next one.
yeah, so let's think about addition for a second. If I had 1 plus 2 plus 4 plus 1,
Mm-hmm.
how do we actually solve this? We don't go
Left or right?
all of this. Right, we go, what's this? 3 plus 4 plus 1.
Ah, so it's like a parentheses.
Yes.
7 plus 1.
Order drops.
And then 8.
Okay, so it's comparing to the last two terms, like you said.
So it's just going to walk down this
Yeah.
thing. And for an OR, it's actually only going to walk down until it finds a true value.
And we can tell it it's true value.
Yeah, whatever.
We lift
It's
the
defined
feeling,
as true or
whatever
false.
not too hot equals.
Yeah, whatever that is. Which I know I have my personal preference for it's not too hot, so that's just
Anywhere that's
like
not
mid
Florida.
60s is perfect.
I'll always look at or as lower standard.
It is. It's a more like I'll take anything. This is a picky eater. This is a
It's
less
very,
picky.
yeah, it's very dating. You're very picky. You say, I want this person to have all these,
Yep.
you know, and then you go, oh, after dating for a while, you know what, they can have any of those.
Yeah, that's really what it is.
Oh my God.
I'm not gonna make that joke. It's really equivalent to a picky eater. Like my ands are I will only eat it if it's chicken nuggets and ketchup and fries. Well, my ors are like, I'm going to eat it whether it's chicken nuggets or tofu or sushi or pad thai. I'll eat it any one of those.
Those are all good.
Yeah, right? Delicious.
And so you said as soon as it hits a true, it's kicking out whatever you're telling it to.
Yes.
Okay.
So that feature called short circuit.
Okay.
Because if there's 10 expressions there and they're all ors, and if one of them is true, it doesn't matter what the rest are. we've hit that one true value.
So it knows to save time to give up.
Mm-hmm.
So do you write it with the most likely thing to be true up front? It depends on what you're doing, right?
Yes. And this kind of optimizations are yes. It's like what's most likely to be true or what's most likely to be false or like
So you're
what do you
kind
care
of
about more.
running down the probability chain as you write further out in Boolean logics.
Mhm. Yeah. And also does the opposite for ands. As soon as it finds a false value, it stops the evaluating.
Okay.
Same sort of short circuiting idea. So that's ands and ors, picky eaters and not picky eaters. The last operator is actually a unary operator called a not, which just flips the Boolean from true to false, or from false to true. So const is night is the opposite if it's is day.
How does that work though? That looks like you're just defining a variable. Is it because it's not in quotes?
Because there's a little bang there. There's a little exclamation point. So
The bang.
exclamation point, yeah, a bang.
The bang.
I thought it bang.
Should
Bang.
bang.
Yeah, get it, I've never heard that. Making sure I understood. Okay.
Yeah. I don't know why that threw me.
Why is that useful?
Sorry.
Well, yeah. So why is that useful?
Yes.
So is it nice outside? I want to know when it's not nice outside.
Ah. Okay.
Yeah.
Oh.
So in order for me to figure out if it's not nice outside, I compute whether it's nice outside and then flip it.
Yeah.
So I can go if it's bang,
Mhm.
parentheses, sunny and not too hot, then it's not nice outside. Yeah,
Fun.
this gets fun fast.
I bet it does.
Why is that useful?
Why is that useful?
Yeah, okay, because
super
like it
useful.
didn't tell
Yeah,
you
you don't have to
whether it
redefine
was
it.
sunny or not.
So, okay, is it
Well,
like,
actually say yeah.
so is it like, okay, you're signing up for, you're logging in or you're signing up, and if you have your username but not your password, then it's
Yep.
not going, it's gonna kick it out, you can't.
Yeah, so we can do some logic. Go if
Exactly.
username does not equal
That's
not,
Okay,
not
okay.
Yeah.
that that negative is looking for the opposite.
Okay.
So like an opposite algorithm, hey, should I close the door? Check to see if the door is not open. Is open is probably a Boolean value.
Okay.
And I'll go, should I close the door? If it's not open, close it.
Yeah, it's hugely beneficial if you're looking through millions of records and only a few are not true.
Okay.
And so you use that, I need to find the ones that are not true.
Mm-hmm.
Also, you won't get bogged down with too many things you're defining, right?
Mm-hmm.
Because you can always just say not something,
Mhm.
and then you just,
Which
you know,
Yeah.
it's the opposite.
Yeah.
In this example, you define nice outside. Is it good practice to define like it's not nice outside, and then in your if nice outside statement you say if nice outside and not nice outside? Like, is it good
Depending on what you're
Just
doing,
yeah.
maybe, but it's really too many double negatives get
Right.
confusing. You should always try to infer the positive. So if we're looking for it, if it's nice outside, then we should go if it's nice outside. If we're looking for it's not nice outside, then we should be looking for if it's not nice outside.
Okay.
Nest the knots. It's
Yeah.
not nice outside.
Right.
Yeah,
Right,
like that's right and that's correct and that would work. Is it not nice outside?
Oh no.
But
Can you double bank?
yeah, you can,
Yeah.
you can double bang, triple bang,
Not nice
quadruple bang.
outside.
We'll get to why double bang is cool in about 20 minutes.
Some
It's
of
like
that
a
time
technical
fixes
term
some of
that's
it.
just like,
So
you know,
it's
like, is this like official?
What, bang?
More you
Yeah,
tell
they
it.
do call it bangers and just.
It's actually called a bang.
Oh,
Yeah, it is called.
I'm just
You
checking.
don't like it.
You have a punctuation mark that's
It's like comic books, you know?
It's a question mark and an
It's
exclamation
almost
point.
The
It's
interrobang.
an interrobang, and it is my. I have a favorite part of punctuation because I'm that person. But interrobang's the best because
I've been
it's a
using
question
them a
mark
lot my whole life.
and yeah, it's a question mark and an exclamation point. And like in chess, if you have to like type them out next to each other, the order you type them in matters. But you can on some typewriters have that symbol all be one thing.
Yeah.
I like it.
This is
I'm so happy you know what an interrobang is. Nobody does.
This is my favorite punctuation.
Yes.
Like it's just so,
I overuse
Yeah,
it.
you don't
and the exclamation question, like, what is this?
That's an interrobang.
I'll go to the
Thank you,
video.
Mark, for drawing up the word, 'cause I kind of wanted to.
Yeah, right.
How do you
I
spell
forget
that?
my charger.
So, Boolean logic. You might encounter these in your experience, and these are just truth tables. These are just the technical definition of what we just established. Saying, hey, given a value of A, given a value of B, what's the result? Now, as we see here, like we said, if both are true, the result's true, else it's false.
That's like the prisoner's dilemma, basically.
Yeah, a lot of those riddles are about like truth tables and like Boolean stuff like that. Here's the ors. No need to memorize these, but just kind of, we already have an understanding of them. These are just like the formal definition.
Wait, what? A and B doesn't mean anything.
No, they're just Boolean values. So like if A is true, if A is true, B is true, the result is true.
Oh, it's giving you values.
If A is false, B is true, the result is true.
So those are the only solutions.
Yes, that's it. So instead of like, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 5 is 6, 1 plus 7 is 8, kind of thing. Like, it's like, we know it's a very closed space, so these are the only variations. So, that being said, back to code.
Yay.
Yay, back to something a bit more tangible. Let's use our knowledge now to kind of compute this. So, current score is 10, the target score is 15, and the tries equals 1. So we're saying, hey, if the current score is less than or greater than the target, and tries is less than 3, that's our expression. That's the Boolean, the value that we're looking for.
So they get 3 tries to get more than 15 points.
Yes. So if this first one, current score is less than or greater than, is less than or equal to target, which is it? Yes.
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 So the first one is true. We're looking for an and. That's a double ampersand for you. Ampersand, ampersand. Tries less than 3, which is just true. So this whole thing equals
True.
true. So it'll run try again.
The order of the greater sign, equal sign, that's very important, right? You
Yeah.
can't switch that around.
Correct.
And that's uniform for all the,
Mhm.
like the plus equals, minus equals, okay, equals always last.
Yep.
So this person would only get 2 tries, right? Because it's being equal to 3.
If try starts at 1. Tries can start at 0.
Oh yeah. Sure.
But
Wait.
can tries can't change this because it's a constant, right?
In this context, correct. But in after programming, they're probably.
Right, so if it was real, then you would want to say let tries equal 1.
And so the way you write if not is if space bang, then that whole thing.
Yep.
And then it would kick you to
Yeah.
else.
We'd have to wrap this
the whole thing.
this whole expression in another set of parentheses,
Okay.
and then put a bang in front of that.
Okay.
So it'd be parentheses, bang, that, and parentheses.
Do you need the else for this to work?
No. You actually don't need else with ifs. Ifs don't need elses. There's also something called an else if.
Right.
Woo! Which we'll see later today when we actually get coding. But it's just another expression.
If you said tries equal to 3,
Mm-hmm.
would you actually get 3 tries, or would it still just be 2?
So if tries was 3, let's work this out. This first one's still true.
Mhm.
But now tries less than 3.
Yes.
No, it's the same.
Steven.
So this would be false. So
then-
now, false. So if we're anding a true and a false,
It's false.
this now is false.
Game
Oh,
over.
I'm sorry. I guess tries less than or equal to 3.
Mm-hmm.
Probably what I was trying to ask.
Yep.
So if it was tries less than or equal to 3, it's still the same.
Mhm.
Is there ever a time where true and false has to be true?
No.
If it was an or. If I switch this logic to be an or, now this is
True.
true.
I guess I'm confused of when to use less than equals or just less than.
Whenever
It just
you,
depends on the.
yeah, it depends on the requirements.
How picky and eager are you?
Yeah. Off by 1 errors are a very common thing. Like how many times, like, oh, 3 tries or 4 tries or 2 tries when I really want 3 tries. Like the off by 1 errors are really common.
Okay.
So good.
I like the temperature thing.
Slime makes me angry.
It's like right? It's terrible. So this basic concept of true and false and expression in Boolean logic, this is pretty universal in all programming languages. Like no matter what language you get to, you're gonna have some like, hey, if this then that. Is this a true or a false value? So like that fundamental thing is super important. But we are in JavaScript. JavaScript likes to have its quirks and likes to have this very powerful uniqueness to it. So in JavaScript, not only do we have true and false, we have truthy and falsy.
Is that ish?
It is. It actually is an ish. So what this means is that every piece of data in JavaScript has an inherent true or false value.
Okay. How do you?
So,
Every piece of data has an inherent true or false value.
correct. So instead of going, if full name is not empty, I can just do if full name.
Oh, okay. All right. That makes sense.
So anything that's so truthy values are any non-zero number. So like if 18, if 21, if 33. If any string, so if hello, if Mark, if Amanda. Or anything that's not a falsy. Falsy values, there's only 7 falsy values.
Which one's not on there?
They're all there. False, 0,
That's what
undefined,
looks
null,
like
man, and the empty string. Empty string is on there twice.
Right.
So it's easier to be a truthy than a falsy.
Yes. So now, kind of a real-world example of this is form validation. Earlier we talked like, hey, if we have a thing that says, give me your username and your password, we can go, instead of going, if password.length is greater than 0, we can just do if password instead. So is password a thing? And that's really how I think about truthy or falsy, is if this variable is a thing. So like, if I query the DOM, and I get nothing back, which some of you tried yesterday, got back a null value, I can go, hey, if this thing exists, if this is a thing, then do something. Else not do something. Because null is a falsy value. So we can use this to kind of make our logic a bit less Boolean-y and a bit more like real-world, closer to English.
That's really cool. That it allows you to be less precise if
Yes.
you know sort of what you're after, but not precisely what the value is going to end up being.
Yeah.
Cool.
Like, I just care that this is a thing. That's all. It just has to be a thing.
Oh, that's sweet.
Yeah.
So if and else are kind of implying the Boolean value.
Yep.
Is there a space between the quotation marks?
Nope. Empty.
If there was, would it be a truthy then?
It would.
Oh.
Yes. Because an empty space is a character. It's the thing. Even though it's nothing, it's still a thing.
So false is just plain false.
Yeah. So like all those equate to false.
Yeah, that means nothing.
Yep.
Man, look, you want to ask.
Yeah, you
I do, but I think one thing I want to ask is on the next slide, so I'm trying to wait, and this is my patient face. Aren't you impressed?
So it probably isn't, because I know what the next slide is. So it probably isn't on the next slide. So ask it.
My question was going to be, like, how do we use this?
Can I?
Oh.
Can I give a PowerShell
Like-
example?
Yeah.
Yeah.
So I use this tons of PowerShell because it has all any methods and any logic. I had a project where I had to attach an app, like an external app to an app, to something in SharePoint. So I had to find all of the sites that did not have a connector connected to them.
Okay.
So I had to go out and call the sites And every site that did not have a connector, which was a falsie, I ran a script that would do a comparison. It would grab the name of the site, grab the name of the connector, compare it and make sure they were equal, and then it would create a connection. So then you're looking for falses, you're looking for failures.
How do you write a falsie into that?
Really, and it was very similar to how you described it, where I had the if statement, if bang, the name, and it said if this is not true, I want you to run the command to create a connector.
And in that case, it could be the failure, the not could be one of many things.
Right.
So it's like, well, is it any one of these failures? The failure being a false, an undefined, a null, and not found, or whatever. So it doesn't matter. It's being a bit more open to it, and a bit more like feely touchy.
That part I get. It's the how you write that into a function that I'm lost on.
Okay. So what that would look like, because it's not on the next slide, I'll just write this out for you real fast. What is the next slide? I know, right? What is it? It's nerve-wracking.
The giant Jar Jar things.
And like if you look back at needs coffee, like if needs coffee is no I need juice,
Mhm.
that's false. So that makes need coffee falsy.
So if which one can you see better, black or orange?
Orange.
Cool deal. So if we have const needs coffee, actually what we can do, instead of needs coffee, redefine that to coffee amount.
Okay.
And coffee amount is equal to,
There's you would want to scroll, right?
size of coffee cup minus coffee drink.
Right.
So it's going to be how much coffee I have. So I have an 8-ounce cup, and I've drank. If I drank 7, then how much coffee do I have left?
One.
What? All right. So now my needs coffee. I can go if coffee amount and I don't need to put any sort of expression there. Because if my coffee amount is anything, if it's not 0,
Ooh.
then I have coffee.
Okay.
So how would you run that console log then?
Else,
Fill it up.
Refill.
refill.
Cool.
Oh, okay.
Cool. Yeah. So there I can say, hey, I can just check and see if it's 0 or not.
You don't have to put if it equals.
Yeah, I don't have to put like if it equals 0, or if it's triple equals 0, or if it's not equals 0, or any sort of weird, more complicated magic.
Right.
I just want to go, hey, if I have coffee, I'm good.
Cool. Thank you.
Now the coffee 7 and the size of coffee 8 that you we would have to define those.
Yeah. Pretend we got those.
Okay.
How important is understanding the falsy values for debugging?
Very much so.
Okay.
I mean, there's like 6 values, and I think they're pretty straightforward.
Okay.
And these are probably 6 values you need to know as JavaScript developers, anyways.
Okay. Did you already go over the difference between those?
Not yet.
Okay.
That's a really good question. Now we can kind of see them all together. Just before we do that, B, you look perplexed. You good?
I think so. I think I'm fighting to not break out the song.
Oh, okay. Works for me.
I'm trying to hold it.
Okay. So, just to kind of circle back, if I wanted to flip my logic, go if I should I refill this, I go if there's no coffee.
Oh, I couldn't bang there.
Yeah, we're putting a bang in there. Then I can be like, hey, if I don't have any coffee, then refill.
That's
I'm
what
gonna
we'll,
shorten
So-
the code.
that's what we'll do for the site.
Else, go back to work.
Yes.
Banger is not.
Yes.
Wait, if not.
Yeah. So if there's not any coffee,
Oh.
is this going to go, hey, what's the truthy value of this?
Mhm.
Give me the opposite of it.
Thank you.
So let's put the ifs on hold. Quick bonus slide. We've been working with querying elements, working with the text content yesterday, right? How can I change the text here? How can I change this? How can I get the value? Well, not only can we manipulate content, we can also manipulate CSS. What? Crazy. What? No way. So here we have a query selector, and every single thing, every single element inside of our JavaScript has a property called class list, which is just a collection of classes that it has. We can either add it to it or remove it. So going back to our example, if we need coffee, we can now select a header on our page, change this text content to go get coffee, and then add a class that says alert. That's like a big red background with like a big coffee grounds doing dancing. And we can actually add that class dynamically. Then once we get coffee, we can then remove that class. So like, I don't know, if we had, like a scoreboard app, we could put some logic in saying if team 1 has a score greater than team 2, and it's the end of the game, add CSS around team 1 to dictate that they won. That might be your homework. Say it again. So like if we had like team 1 and team 2, if team 1's score is greater than team 2, and the game is over, add the winner CSS to team 1. So now we can kind of add some logic to our page and kind of go from there.
That's like the epic mode, isn't it?
Might be.
So it completely changes the class.
It adds this class. It doesn't change the class.
Okay.
It just adds it.
No.
Oh, so it'll
What
be
does
a
it add?
combination of both?
Yep.
Okay.
So like, if this element had other classes, it would actually add that class to it.
Will it override properties that have?
Potentially, yeah.
Okay.
Did you
Yeah.
say H1? Be constant H1 and then H1 dot class list,
Yeah.
and then you're adding a class to H1.
Yep. And then whatever classes it has whatever it has in HTML plus whatever you added in JavaScript.
Would you have to redefine the class, the CSS, or you do it all?
No, I mean the class has to be defined in CSS.
Like if we're trying to make it like blue.
Right. You have to define a blue CSS class somewhere.
So you can have this JavaScript named, right? Like
Mhm.
camel case.
We'll have some fun with this for our example today.
Is there an advantage to using this way instead of CSS variables, or it just depends on?
Two different things. CSS
Right.
variables are for stuff inside of CSS. This is for if you want to dynamically change the CSS after the page loads.
Okay, but you can do the same thing with both tools, right? Or
No, CSS variables are for storing values inside of CSS.
okay,
This is purely JavaScript.
but you can use JavaScript to manipulate those CSS variables.
Not to my knowledge.
Okay.
Wait, so you have an ID tag in there too?
Yeah.
Because that's what that thing is called in HTML, right?
Yes.
Um,
Because whatever I'm looking for in HTML has an ID of my section.
Ah.
Yeah.
I did find an exercise that you do that, but I'm actually interested to see like how.
I would love to see it.
Yeah, I can show it. Yeah. You can't get it to work, so.
So then the way you have other class listed in CSS is, I don't know,
Yeah, like-
everything turns green and blinks or whatever.
Mhm.
And it does not get used until this happens in JavaScript.
Correct.
Cool.
Cool.
So that seems like a good use for IDs then. Sorry.
Yeah, it's a great use for IDs.
Because you
And-
can find it in the HTML and then add a class to it.
Yep.
So that seems very useful.
Yeah. And we can
Wait,
conditionally
rather than
add classes.
Because like ID and class are like kind of the same thing. Like you
Right.
just add class, ID, whatever in the HTML tag.
Mhm.
So the query selector is looking for my section. When it finds it, it adds a class to
Mhm.
whatever
Only-
HTML tag that is.
Only that tag too. It's not like It
Right.
doesn't do anything crazy. It's not
It's specific.
unexpected grabbing something else.
What if it's like a P tag?
No, yeah, it's fine.
Does it affect all the P tags?
Nope, it's just that thing with the ID.
If you add ID to the P
Oh,
tag.
but you gotta add ID to it. Oh, okay.
Right. I guess I'm having a hard time seeing the advantage of adding an ID to a class.
It's an ID to an element.
Okay.
Yeah,
Whenever you want to target a specific element.
Okay.
because you could query select an element, but then it changes all.
So, we've covered a lot of ground in the past hour, in the past 45 minutes actually, only, right? It's 10:53. Let's take it's 10:55. Let's take a 10-minute break. Come back at 11:05, and we'll build a number guesser together.
Oh.
Yay!
Go back one slide.
So yeah, come back in an hour, or not an hour, 10 minutes.